Hi, this what you see is my 1.5 ton AC and that's my 12 volts battery. The battery is connected to an inverter with a current rating of 150 ampere hour and manufactured in July 2016. And the inverter rating is 1500 watts continuous and 3000 watts peak. Now let's turn off the AC and remove its power plug to connect it to my inverter. Let's turn it on. And as you can see that the battery voltage is only 11.7 volts, but let's try it anyways. So here I'm going to connect a DC clamp meter to measure the current drawn by the inverter from the battery. Here as you can see that it is drawing only 0.5 amperes. So let's turn on the AC. You can see as soon as I've turned on the AC, there is large amount of current drawn, 70 amperes. And the AC turned off at 90 amperes. So now it's time to make a battery charger, charge the battery and test it again. This is a computer UPS transformer. Let's do the resistance check of the high voltage side. 4.3 ohms. 13.7. We have to go for the highest. 14.8. Good. And finally we have 15.6 ohms, the highest. Now this what you see is a discarded PWM solar battery charger that I'm going to use in this project for safe battery charging. Here instead of the solar panel I'm going to connect this battery charger, and its output is close to that of a solar panel, 17.2 volts. So the controller should sense it as a solar panel. First I'm going to connect battery terminals of the PWM controller to the battery. Here as you can see that the controller has sensed the battery connected and it is indicating solar on and inverter on. Now solar is on even though I have not powered the power supply up because the capacitor is charged right now. So let's turn on my battery charger. And here I have finally connected the charger, which means the battery is charging right now. The battery as you can see is drawing around 5 amperes and it is going to disconnect itself around 13.7 or 14 volts. So the battery has been charging for 12 hours. As you can see, the temperature is reaching as high as 66 degrees centigrade. You can see the drawn current has reduced to only 3.5 amperes since the battery has gained some charge. So let's disconnect the charger and check our new battery voltage after charging. Our battery voltage has obviously increased to 13.2 volts from 12 volts. So I think we can test the AC now. So now I'm connecting the AC once again to find out if it works. For some reason the battery voltage has reduced to 12.6 volts because the battery is old. Turned on the AC, the voltage is reducing. The current is fluctuating on the meter, 1.5 amperes. Let's turn it on. The current has started to increase, 37 amperes. The voltage on the inverter is reducing really fast. More than 100 amperes. Oops, and it's dead. So here as you can see that I've changed the battery, same power rating, and let's test it again. Turning it on, you can see that it is flashing 12.7 volts. Let's turn on the AC. You can see it is drawing 50 amperes and the voltage is dropping. Let's see if it works this time. Wow! The inverter is handling the load and the battery is also handling the current. 100 amperes we are doing. And the AC is working. That is quite good. It is brilliant. So yes, we can run the AC on one battery but not for long because huge current is drawn. You can see that the voltage has dropped to as low as 10.5 volts and it is going to cut off at 10 volts. So it is not going to last for long. We are doing around 109 amperes. 110. That's very good. So yes, we can run a 1.5 ton AC on a single battery. So turning off the AC. And before I could turn it off, it turned off automatically.